In this video, I'm going to be going over how we can use the other trig functions aside from sine and cosine. So this first example says the point negative root 3 over 2 comma 1/2 is on the unit circle. Find sine of t, cosine of t, etc. So our angle t is here. And what we want to do is we want to find the value of the 6 trig functions for that angle. So we want sine of t, cosine of t, tangent of t, and then we want cosecant of t, secant of t, and cotangent of t. And the reason I've written them like this is because sine and cosecant are reciprocals of each other. So those ones, they kind of go together. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So if we can figure out what's going on in this left column, the right column here comes to us pretty easily. So looking at this this diagram, if we can think about this as a right triangle, those coordinates, negative root 3 over 2, that's the x-coordinate. So that's this horizontal length of the right triangle. And then 1/2, I could label the vertical value or the vertical side of that right triangle. And then I can verify this, but this is a unit circle because I have 1 as the radius here. But if you're not sure, you can use the Pythagorean theorem. 1/2 squared plus negative root 3 over 2 squared, and let's call that r squared for radius. So 1/2 squared is 1/4 plus negative root 3 over 2 times negative root 3 over 2. Well, in the numerator, I get 3. Denominator, I get 4. 1/4 plus 3/4 is 1. So r is equal to 1 here. Now, the reason that is useful is because I need all 3 sides to figure out all 6 trig function values. All right, so I'm going to put t down here. So sine of t is sine of an angle is equal to opposite over hypotenuse. So this is 1/2 over 1, which is just 1/2. Cosine is equal to the adjacent over hypotenuse, so negative root 3 over 2 divided by 1, which is just negative root 3 over 2. And then tangent is opposite over adjacent. So this is, let me move this here. This is tangent of t. So opposite of that angle t is 1/2 over negative root 3 over 2. We could keep it that way. We don't. This is called a complex fraction when I have a fraction inside other fractions. It's best to remove any complex fractions. So I could make this negative 1 over root 3, or I could take that and multiply it by the radical that's in the denominator, and what I end up with is negative root 3 over 3. So either way is okay, and this way we just say has been rationalized, or the denominator, I guess we should say the denominator is rationalized. That just means we don't have a radical or a square root in the denominator. But either of these is a-okay. Now, to get cosecant, secant, and cotangent, all I do is I take the reciprocals, and then, or I guess these corresponding values, and then I just take the reciprocal. So cosecant is the reciprocal of sine, so that's 2 over 1, or just 2. Secant is the reciprocal of cosine, so negative 2 over root 3. If I rationalize this, it's negative 2 root 3 over 3. Either of those are okay. And then for cotangent, well, I could take the reciprocal of either of these. If I take the reciprocal of the first one, I end up with negative root 3 over 1, or just negative root 3. And that's the one I'll choose because if I use negative root 3 over 3, then I would need to rationalize. So by using that first one, the reciprocal gives me something that is rationalized. All right, so those are the values. So kind of summarizing, one thing I didn't notice when I read these instructions is it says that that point is on the unit circle. So that guarantees that the radius is 1, and I didn't need to do that Pythagorean theorem business down there. Also, one thing to notice, it doesn't say this explicitly, but these coordinates, these appear on one of the special angles in the unit circle. So the angle there is, let's see, 150 degrees, or in radians, 5 pi over 6. Okay, so this question doesn't ask you that, but that is what the angle T is equal to. All right, moving on to this next one. This next one is quite similar to the previous example. So the point root 2 over 2, comma, negative root 2 over 2 is on the unit circle. Find the value of the 6 trig functions for this. Okay, so let's see, sine. Another way of thinking about this is that in this first example, I used the idea of SOHCAHTOA. And when we use SOHCAHTOA, that always corresponds to, or those acronyms are related to a right triangle. So that's one way we can do it. Another way we can do this is if I'm dealing with something on the unit circle, which just means the radius is 1, I can let sine always correspond to the y coordinate. I can let cosine correspond to the x coordinate. And then for tangent, I can let that correspond to the ratio of y over x. So this is just a second way to do it. Sometimes this might be easier. Sometimes using a right triangle will be easier. It just depends on what we're given. So let's do this using the xy relationship here. So sine of t, so sine is just the y coordinate. So this is negative root 2 over 2. Cosine is the x coordinate, so that's positive root 2 over 2. Tangent is going to be y over x. Now, what you'll notice is that these values, the y value and the x value, are the same. I just have a negative. So this is going to come out to negative 1. But if you want to take the long way, you'll see that y over x, I have the same values. They're just one's positive, one's negative. All right, and then getting the reciprocals of this, cosecant of t is just the reciprocal of sine of t. So that's going to be negative 2 over root 2. Secant of t is positive 2 over root 2. And then tangent of t, well, that's the reciprocal of negative 1. That's 1 over negative 1, which is still negative 1. Okay. One thing, let's see what happens when we rationalize cosecant and secant here. If I multiply by root 2 over root 2, I get negative 2 root 2 over root 2 times root 2 is root 4, which is equal to 2. And those 2's can cancel. So this one comes out to be negative root 2. That's a much simpler way, but again, either of these are okay. And then I could do that same thing for secant of t, and I would end up with just a positive root 2. But again, either way is okay. All right, the next example says, find the value of the 6 trig functions when we have an angle of pi over 6. So pi over 6 is here. That is one of the values on the unit circle. And the coordinates that correspond to pi over 6 are root 3 over 2, comma, 1/2. Okay, so sine of, I'll say pi over 6 is equal to 1/2. Cosine of pi over 6 is equal to root 3 over 2. Tangent of pi over 6, well, this is the y coordinate over the x coordinate, so 1/2 divided by root 3 over 2. Anytime I have that, the 2's are going to cancel, and I can write this as 1 over root 3. And then to get the reciprocal functions, I just take what I've already found. So cosecant of pi over 6 is 2 over 1, or just 2. Secant of pi over 6 is equal to 2 over root 3. And then cotangent of pi over 6 is equal to root 3 over 1, or just root 3. Okay. What we're going to do here is we're going to use the reference angles to find the value of the 6 trig functions. So this first one, our angle is negative 5 pi over 6. So let's locate that. Because this is negative, I'm going to be going in the clockwise direction. If you're not sure where to end, you can think, well, 5 pi over 6 is over here. That would be positive 5 pi over 6. So if it's negative 5 pi over 6, I'm going to go in the opposite direction, and I'm going to pass through the same angle, just going clockwise. So the reference angle for 5 pi over 6 is pi over 6. And the coordinates for pi over 6, well, that's what I found up here. It was root 3 over 2, comma, 1/2. So because this is in quadrant 3, this angle, negative 5 pi over 6, the signs for each coordinate are negative. So to answer this question, to get the value of the 6 trig functions, so there's sine of negative 5 pi over 6. I'm going to use the sine value of pi over 6, which is 1/2. But because this is in the third quadrant, my value is going to be negative. I'm going to proceed in the same way. Cosine of negative 5 pi over 6, well, in the first quadrant, that's root 3 over 2. In quadrant 3, it's negative. Tangent of negative 5 pi over 6. Well, here, remember, tangent is y over x. So in quadrant 3, both of those are negative. So I get a negative divided by a negative. So my value here for tangent of negative 5 pi over 6 is going to be a positive value. And we saw this already up here. It's positive 1 over root 3. And then going through for cosecant, secant, and cotangent, the signs for the reciprocals are all the same as what we previously found. Okay, so cosecant for negative 5 pi over 6, well, that's going to be the reciprocal of negative 1/2, so negative 2. I have secant of negative 5 pi over 6, so that's the reciprocal of negative root 3 over 2, so negative 2 over root 3. And then, oops, this shouldn't say tangent, this should say cotangent. And that's going to be positive root 3 over 1, or just root 3. All right. We have one last question here. Use reference angles to find the values of the 6 trig functions for 7 pi over 4. 7 pi over 4 is down here. The reference angle for that is pi over 4. And the coordinates for pi over 4 are root 2 over 2, comma, root 2 over 2. This is quadrant 4. 7 pi over 4 is in quadrant 4. The signs for the coordinates are positive, negative. So x is positive, y is negative. So going through, sine of 7 pi over 4. That's going to be the y coordinate. So root 2 over 2, but it's negative. So negative root 2 over 2. Cosine of 7 pi over 4. That's going to be positive root 2 over 2. Tangent of 7 pi over 4. Well, this is the same x and y coordinates where the y value is negative. So remember, tangent is y over x. So this is negative root 2 over 2 divided by root 2 over 2, which is negative 1. And then finishing this off, cosecant 7 pi over 4 is just the reciprocal, so negative 2 over square root 2. Secant of 7 pi over 4 is positive 2 over square root 2. And then cotangent of 7 pi over 4 is just negative 1. And like we saw above for these two, if I was to rationalize this, this would just come out to negative root 2, and this would come out to positive root 2 if we were to rationalize those. But again, either way is okay.